Good evening. We're about to go live, so I'm just going to check my sound, and then once the sound's all good, we'll get going. So we're about to go live. Sounds pretty good to me. Just going to check my sound, and then once the sound's that's all off there. Very good. And okay, we'll just go to So last night I left you with a bit of a problem to determine the graph between 2 points. And here they are here. As you can see, -3, 7 and 5, -1. So my recommendation is always to draw it. Always draw your diagram. I'm a very visual person, and I like hands-on, so I like to get in and get it done. So first of all, here's our X and Y, and our first point is -3 and 7, so that'll be up there. Like that there. And then our next point is 5, which will probably be about here, and -1. So there's the point -3, 7, and this is the point 5, -1. Very important to get those in. And this here is our graph, and as we look at it, we can see, so just some things, just by looking at it, we can see that it's decreasing from left to right. So the gradient, we know the gradient is negative. I just put a little negative. All right, there we go. And we can see there that the y-intercept is probably going to be between 0 and 7 here, and the x-intercept is going to be somewhere between 0 and 5. So if we use the formula, we go x1, x2, oh, wrong, x1, y1, and here we get x2, y2. So m, the gradient, equals y2 minus y1 over x2 minus x1. So I think probably need to just go back and check that, just to make sure that is. So just check that. Yeah, yes, mx, there it is there, m x y2 minus y1 over x2 minus x1. And let's just check the other one as well, and that is y minus y1 equals m x minus x1. And that'll enable us to get the equation. So they're the two equations that we use there to do this. It sort of it's common sense, really. So I'm just going to, let's see, so y2 is -1. And then we subtract y1, which is 7. -1 minus 7. Okay, it's hopped about. I must have pushed the -1 minus 7, and this is m here, our gradient. -1 minus 7 over x2, which is 5, minus -3. Okay, and so that equals, now it's just, that's -2 minus -7, that will give us -8. Okay, and 5 minus -3 is 8, and that will give us -1. So our gradient is -1. All right, so it's a one-to-one gradient. So we just looking at the graph, so we've got all this information there. They're all little clues and things that help us. We know that then this value and this value will be the same, the same quantum. This will be, well, the same actually. That'll be plus whatever it is, and that'll be there. Right, so now we go into the second formula. The second formula there, which we've got there. We want to move this around a bit, but perhaps we'll just go up to there a bit, give us a bit of room. Right, our second formula, I'm going to try and lock that in place. So we got y minus y1, which is 7, equals -1 m, and then we've got x minus x1, which is -3. All right, -3. So we get y minus 7 equals -1. So we'll expand that. Well, we'll write this here equals negative x plus 3. Okay, so we get y minus 7 equals negative x minus 3. So it's important that we there. So the -1 times x is, well, we worked out the brackets first. X minus -3 is x plus 3. And then -1 times x is -x, and -1 times 3 is -3. And then here we will add 7. Okay, and so we get y equals -x plus 4. Okay, and that's the equation of the graph. Y equals -x plus 4. And we know that when y equals 0, this will be 4. And we also know that when x equals 0,
here's a nice takeaway challenge for tomorrow.
So there we are, we've got the graph. Now that last little bit, we only know that because the gradient is 1, therefore these intersects will have to be
2.
the same
Plug
if
into the point slope form.
that's the case there.
3. Rearrange into
So,
y equals mx plus c form. Give it a crack
yeah,
when you get the chance. I'll be ready to check your working tomorrow.
there we go.
Catch you then, Chief.
All right. So let's just check that out with ChatGPT. So we'll just go y. I don't know what crazy things it's going to do for us tonight. Equals negative x plus 4. Y equals negative x plus 4. And let's see what it says. So we've got the gradient of negative 1 and y equals negative x. You're rolling. Want tomorrow's one to involve a fractional slope or maybe vertical horizontal line. Next. Okay, so what I want to look at now is we can determine the gradient between 2 points. And we actually did some the other day where I gave a point and then we determined graphs through it with a different gradient. But one of the other things about this is similar to, doing things and undoing things, is that we can just some questions we get, we just have to recognize the graph. But just before we do that, let's just have a look at something that's quite universal. And this here is this is our y and x. Now, if we take the graph y equals x, y equals x. That's a 45-degree line. It's going through there. Is it in the format of y equals mx plus c? Well, yes it is. In this case, m equals 1 and c equals 0. And if we maybe look at another graph, so if we want to look at this here, y equals negative x, we can see that it's just the same graph, but it's reflected in it. It's actually that's actually at 90 degrees there, and I think we've looked at that the gradient of this one is the negative reciprocal of the others, so it makes it at 90 degrees. So in this case here, y equals negative x. Y equals negative x. We can see that m equals negative 1 and c equals 0. Right, so sometimes we want to translate a graph sort of up or down or in a different place on the plane. So if you look at the graph y equals x plus 1, that'll move this graph of y equals x. It'll just move it parallel and through 1, like that. And if you wanted to, and then you get a 1 in there. So that's y equals x plus 1. And so you can get all sorts of lines up there. If you want to change the grade of it, there's if you change the gradient to a half, 1 over 2, so it flattens it. So like for instance, if you wanted to look at y equals 1/2, y equals, hang on, yeah, y equals a half x, it would be out there like that. So it would, there's the gradient, it would go up 1 and out 2. So that would make it a lot flatter. And if you come up here a bit steeper, y equals 2x. And then you can also add to those. You could say y equals 2x plus 6. Through there like that. So that is y equals 2x plus 6. So it's quite easy to sort of, with practice, to see what the graph is. So one of the things that you might get asked to do is to say, what is the equation of this graph? What is the equation of the graph below? And so you might have a like this here. Okay, and that's y, that's x, and here's your graph here. So this point here might be -4. This point here might be 2. Okay, and all right, and this is your graph. So you've got to identify that graph. So there's a number of things you can do when you just look at that one. Straight away, you could see that the gradient is positive because it's increasing from left to right. It's got a rise of 1, a rise of 2, like it's going up 2, and the run is 4. Rise over run, which equals a half. I probably haven't drawn it very well. It's probably a lot flatter than that. This is true that sometimes things are not drawn to scale, so it's not necessarily that you're going to get a scale one of this. Yeah, so you can see that gradient is a half, rise over the run, and we can see that that would then be the graph of y equals 1/2 x plus 2. So we can see that when x equals 0, y equals 2, which is tick there. And when y equals 0, 0 equals 1/2 x plus 2. So negative 1/2 x equals 2, and x equals negative 4, which is what we get here. So this is the graph of y equals 1/2 x plus 2. All right. And so, again, this is another little skill that you can have. Now, quite often, a lot of this information and stuff is not necessarily the answer to what you want, but it certainly helps and gives you confidence to understand where these things come from. So, yeah, that's a little bit about straight line graphs. And now, well, let's just recap. We can draw them. We can draw them one through a point. We did one the other night where I gave you a point that was whole numbers, and then we came up with two graphs that came through it, so that we could do the simultaneous equations, and then we could solve the simultaneous equations. So you can see that it's all going around. One of the important things is this idea of, two equations two unknowns means you can solve it. You can solve it. If you have two unknowns, you'll need two equations. If you have three unknowns, you'll need three equations, sort of as a bit of a general rule. And also with linear equations, you just sometimes you just have one equation, but in certain situations you can solve things. So let's maybe just do a graph here, see if we can identify this graph. So we'll just do this here like this, and let's just say it's sort of let's say that's the 0.52 there like that, and let's say that the y-intercept is, let's say that y-intercept there is at 3. What is that? What is that graph? What is that graph? How can we determine what that graph is? Okay, so we know that point there is 5. Oh, I haven't drawn it very much to scale, have I? And this point here, oh, that's not right. That can't be right. I'll because if that's the 0.2 there, then that can't be 3. So let's put it around the other way. Let's make it a bit more sensible. Oh, okay, that's the 0.52 there. But let's make that 0.25. I've got that. It'll make more sense. Okay, so let's make that there the 0.25 like that, and then this point here can be 3. So that makes more sense now. So that would be the 0.5. And this here would be the 0.2. And this here would be the 0.3. So if we look at here, we can see that there is 2. From 3 to 5 is 2, and from 0 is 2. So we can see that the gradient equals rise, which is 2, over 2, which equals 1. We can see that it's a positive gradient because it's rising up from left to right. Right, now it actually goes through the 0.25. So we could just use the formula from earlier. We could just use that formula that we used earlier. We could say y minus y1 equals m x minus x1. And then we can just use that point there. So we got y minus 5 equals 1 x minus 2. And so now we get y minus 5 equals x minus 2. And then we can add 5 to both sides. And we get y equals x minus 2 plus 5 equals x plus 3. So this here is the graph y equals x plus 3. And if we could check that out using ChatGPT if we wanted to, just to make sure we've got it right. Especially if you're on your own, you can use this. So a straight line goes through the point 2, 5, and it crosses the y-intercept at 2. What is the equation of that line? So there we go, and let's unpack 2, 5, yes, and the y-intercept is 2, so it passes through 0, 2. See? And you can see there that's why it works, is because it's got 2 points, which is what we did at the beginning, but it's just been formulated in a slightly different way. And I don't think it's got it right. It's got a half x. I don't think that. Oh, okay. Oh, I've given it some wrong information. I've given you some wrong information there. It actually passes through the y-axis at 3. So the correct graph passes through the y-axis at 3. Oh, that was there, but we learn. So it's important to be exactly right. So there's the slope 1, and now we're onto it. Y equals x plus 3. So we've got that right. Okay. Now earlier on it said suggested. Okay. Okay. So let's what were we doing there? Yes. Let's we'll just reinforce this one more time overnight by finding okay, we'll just reinforce this. Okay, we'll just reinforce this one more time. So the question for tomorrow would be to determine the gradient between 2 points, but let's have a fractional slope and, well, make it reasonably complex so that you can test us, and then we'll move on to the next topic. Perhaps you could even suggest the next topic if you wished. Let's see what happens. So this is for tomorrow. So we've done a half hour, which is enough for maths. Find the gradient slope. Okay. So find the gradient of the line that passes through those points. Okay, just the gradient. No, I think we can do the full equation. So, yeah, find the equation of the line between these 2 points, -4, 7, and B2. So, and we'll come back and have a look at that one tomorrow. So, yeah, there you go. Another half hour of maths with Maurieo. Feel free to ask me any questions, email or whatever. I'm happy to answer them. And, if the time's not suitable for you, let me know a suitable time and I can go live maybe. I'm not going to get it. Well, sometimes I'm up at 2 o'clock in the morning, but, a convenient time. So it'd be awesome. Thank you so much. Good night and good gardening to you all.